everyone, myself Shiksha Kaushal. I have done my bachelor's as well as master's in chemistry honors from Guru Nanak Dev University, Amritsar. The topic which I am going to discuss is kinetic analysis of a chemical reaction and energy surfaces. Okay, whenever we talk about a chemical reaction, we are always curious about the pathway which is being followed by a molecule in order to get converted from a reactant to a product, and what are the molecular structures which are getting formed in between of this pathway. So the two such structures that we know are activated complexes and intermediates. So what are these terms? Now let me explain this by first explaining the term energy surfaces. So what are energy surfaces? Let me explain this by taking a physical world example, that is hiking. Now imagine hiking a mountain range having number of hills and number of valleys and mountain passes which leads from one valley to another. Now here I have drawn this three-dimensional topological map. In this you can see that these black spots here represent the valleys. Now we know that the valleys are low altitude surfaces. Now in chemistry this altitude represents our energy. It means these represents the molecular structures which are low in energy, or we can say which are stable. So these are reactants, products and intermediates. So here comes our term intermediates. Now on the other hand, what are the transition states? When a molecule is moving from one reactant to product, the molecule is moving along the energy surfaces like this. Now the top of this pathway, the top of this mountain pass is what is known as activated complex or transition state. It is the highest energy molecular structure. Now let me explain intermediates and transition states by giving their definition. So intermediate is a molecular structure that lasts longer than a typical bond vibration, that is 10 raised to power minus 13 second to 10 raised to power minus 14 second. Now but a transition state is a molecular structure which lasts equals to the time for a typical bond vibration. Okay, so here I have explained these terms. Now what is an activation energy? Now for simplicity, let me project the this three-dimensional topological map in 2D. So this is the 2D projection of this structure. Now in 2D we can see that here I have drawn the same thing. These are valleys and this is the peak which represents a transition state. Now what is this gap? This gap is the activation barrier to the reaction, or in chemistry this is called as the activation energy, which is denoted by EA. Now what is this plot overall called as? This is called as the reaction coordinate diagram, and the reaction coordinate diagram, which is the plot of the pathway followed by the molecule by taking potential energy on one axis and reaction coordinate on the other. Now let me explain this further by taking examples. So let me take our favorite examples, that are SN2 mechanism or SN1 mechanism. In SN2 mechanism we know that this mechanism follows formation of this complex. This complex is highly unstable and is called as the transition state. Why? Because we can see here that this carbon is forming 5 bonds, which is very unusual. On the other hand, if we talk about the SN1 mechanism, in this there is this formation of intermediate, which is much stable as in comparison to this transition state, because here the positive charge is being stabilized by these 3 alkyl groups through inductive effect. Now if I draw the reaction coordinate diagram for SN2 and SN1, for SN2 it is very simple as I have discussed, because this is a single step reaction. But in case of SN1, we have this two-step reaction and these are two peaks. Now, this represents the intermediate. Now, we can see that there is a large difference between the activation energies of two peaks. So, which tells us that the first step having the activation energy much larger than the second is a slow step. Now, what about the rate? We know, if we have studied in chemical kinetics, the rate of the reaction is directly proportional to the concentration of the reactants. In first mechanism, that is SN2, it is very clear that rate is directly proportional to the concentration of the reactants. But what about the second, this SN1 mechanism? In this case, it involved two steps. So, which step is going to determine our rate? So, point to be noted here is that in case of the multiple step reactions, the slow step is the rate determining, or we can call rate controlling step. So, this is the step which is going to determine the rate. So, rate in this case will be directly proportional to the concentration of this alkyl halide. Now, I have tried to give you an insight about the energy surfaces, about what are intermediates, what are activated complexes, and by giving some examples. I hope you liked it. Thank you.